Hello everyone, welcome back to my channel. If you're new here, my name is Ronak and I'm a statistician. In this video, I will give you a practical intro on our programming software, RStudio, and running some descriptive statistics analysis. So, first step is to download and install the program. You can download it for free from its original website, cran.r, which stands for Comprehensive R Archive Network. In this website, you'll find different versions of R, and based on your operating system, you can download it for Windows or Mac. But after downloading and installing R, we need another environment, which is called RStudio. RStudio is an environment that we run our code, but here's the question: why don't we just run codes in R? Because RStudio enhances the functionality of R and it is more comfortable to work with. Of course, RStudio does not replace R, and we still need to install R in order to run our RStudio. So in this tutorial, I'm going to show you some descriptive statistics like how to import data, calculating statistical measurements like mean, median, standard deviation, and variance, handling missing data, and finally graphing data using histogram and boxplot. So let's get started. First of all, I need to show you what are the different sections of RStudio. So in RStudio, there are 4 sections. Console is a place where R is waiting for you to tell what to do, and where it will show you the results of a command. You can type commands directly into the console, but they will be forgotten when you close the session. So that's why we need another environment, which is RScript. And it is where you write and run your code. You can open it from File, New File, and RScript, or simply just click on this new file icon over here. And the next session in the upper right corner over here is the environment history, connections, and tutorial. Is the place where you can see the variables that you defined, data, and history of your code that you have run. The last section is files, plots, packages, help, and presentation. It is a section where you can see the files in your folder, plots that you have created, and R packages that are installed in your R program right now. So, before continuing, one important thing has left to tell, and it is the environment that you need to create on your computer for each project. So, you need to go ahead and go to the upper right corner of your window and click on this cube icon, which is the letter R within it. Then click on New Project. So here you can choose whether you want this new project to be in the previous directions of your previous projects or a new one, which obviously here we choose the new directory. Then click on New Project and then name your new directory, for example, Basic Stat, and create project. You have a new project environment defined and saved on your PC. Now, after all, we're good to go to run our codes. So I'll start with a basic one, and it is inputting a data vector into R using the assign operator. For example, suppose we have a sample of 5 infants with ages of 6, 12, 10, 7, and 15. To enter this data into R and give them the name age to this data, we use this assign operator and C function for creating a column vector. So we run this line, and to print an object, we just enter its name, which here is age. And here is the vector. You can see it over here in the console. So for now, we go on and let's see how we can import datasets into our script. If you know the name of the file that you want to bring into the R script environment, just simply use read.csv command and enter the directory directly into it. So, like this line of code. But don't forget to mention that the file is of CSV type because it will throw an error otherwise. Now we entered our data set. We are ready to calculate some statistics. So the first one is the mean function. The mean function calculates means from an object representing either a data matrix or a variable vector. But for mean of the column, for example, sale price, we need to determine which column specifically. It can be done in various ways, like using $sign operator, like the line of code that is over here, mean df $sign sale price. So we run it and you see the result. And the second method is just simply call the name of the column, like mean df and bracket name of the column, which is sale price. And you see we get the same result. The third method is using column index. You should count and see which number is the index of your column and just simply put it in this bracket. You see we get the same result again. And the last method is using column means function. This method is useful for when all of your variables are numeric. And you should know that if there are some non-numeric variables in your data set, it will throw an error. Yeah, you see? It throws an error because we have non-numeric variables in our data set as well. So for median and variance, we can do the same process and you see the results. But for having a summary of the data set, including minimum, mean, maximum, median, and quartiles, we just simply use the summary function. So we run it and you see these values for each column or each 82 variables of us. But notice that for categorical variables, we only get the type and the number of observations or length. We can also see the number of missing values presented by NA for some variables that have missing values. So as you can see, there are some missing values in our data set. You need to know that most functions in R handle missing data appropriately by default, but a couple of basic functions require care when missing values are presented. But to check for missing data with the measurement variables, you can simply use summary command, the thing that I just showed you, and saw the missing values, which is presented by null or NA. To deal with these missing values, you can just simply exclude them or just replace them with the mean value of your data set. Here we just exclude them with this line of code and we just run it. In the next step, we want to visualize our data using graphs, and first chart would be histogram. I have defined a new variable called myHist where I'll define my histogram plot. I wanted to give me the plot for sale price column in 30 pins, and plot is equal with false because we want to define the titles in a better way, in a more prettier way by plot function. So plot function has many properties, but for now we just define data set, border to be false, because we don't want the border to be bold, and main, which is the title of the plot, and label of x-axis to be shown as sale price. So run it, and here is the result. You see we have some outliers over here. Okay, move on to the second plot, which is boxplot. You can simply create a boxplot by boxplot function. And the rest is just the same as the histogram plot, but we can define the color we want here by the number of the desired color in the color palette. And we run it, and here is the result. You see it shows the outliers as well. So that was it. That was few simple descriptive statistics analysis in R, and I hope you liked it and found it helpful. If you did, please like this video and subscribe to my channel for upcoming videos. I'll see you in the next video.